So specific heat of gas, it varies from 0 to infinity. See, this may have some positive and negative values. So molar specific heat at constant volume, that is CV. So in this one, same words we can write. Amount of heat required to raise the temperature at constant volume, only we need to add. Same thing. Amount of heat required to raise temperature of 1 mole, because we are saying molar, of gas, as we are talking about gas. Through 1 K or 1 degree Celsius at constant volume. So CV equals to 1 by N dQ by dt. B. Specific heat at constant pressure. Same thing at constant, we need to add. Same thing. Mayer's relation Cp minus Cv equals to R. And R value is 8.314 joules per molar Kelvin. Can you all see my screen, right?
Yes, sir. Yes, sir.
Okay. Are you done writing? See, previously we just saw only a few ideas about these processes. Now we'll properly discuss about that. All this thermodynamics process. Isothermal, adiabatic, isochoric, isobaric, cyclic. Can I scroll now? Samhita, done writing?
Yes, sir.
Okay, Janvi, Akshit,
Complete.
chalo, ठीक है. We'll go for thermodynamics process. So first one here, that is isothermal. Now, come on, quickly recall what is isothermal process. Tell me, come on, fast. I want you to tell me just about that. Like, what is those processes? Yeah, tell me, I'm waiting. What is isothermal process?
Temperature constant, sir.
Temperature constant. So if you want to draw temperature constant, how will you draw? What we wrote before? Isothermal process, temperature constant. So all this heat is converting into your work done. Now we have work done as PdV. So P and V, they are inversely proportional to each other. So whenever we want to draw inversely proportional, we will draw one rectangular hyperbola. So if thermodynamic process is happening here in surrounding, in that, what will happen? Temperature is constant. So PV equals to nRT. So temperature is constant. So du equals to 0. So dq equals to dw, which is equals to pdv. That's what we wrote before also. So nRT integral of dv by v. So finally we get dq equals to nRT log E, V2 by V1. So to remove log E, we will do 2.303 nRT log base 10 V2 by V1, that is dq. So your graph will become like this. P as pressure in y-axis, volume, and T is constant.
Sir, why is volumes dV 0?
Sorry?
Why is dV 0?
du.
Yes, sir, why is that 0?
See, when there is a no temperature is constant, so du is what? About d change, dt. Du is related to dt. So if there is constant temperature, so change of temperature is 0. If I say T2 minus T1, T2 and T1, they both are same, so it will become 0. So therefore, internal energy is 0 because internal energy is related to change of temperature. There is no change, that means internal energy is 0. So in the equation, dq equals to du plus dw. So if du is 0, that means heat is directly work done. Got it? Understood?
So internal energy is 0 of the system because temperature is constant.
Yes. Because internal energy is related to change of temperature. So you can so you can write here itself so that you will not forget. Internal energy depends only on temperature. So you can remember this. Chalo, take it next. Next is your adiabatic. So can you tell me about adiabatic? Come on, quickly. What about adiabatic? No one?
There is no exchange of heat between system and surroundings, sir.
Exactly. So no change of heat. Now in this case, what will become 0? dw, dq or du?
dq equal to 0, sir.
Yo. So let's see about that. So if system is isolated, that isolated from surrounding, that means no heat flow in or out. So whatever change happening during this process, that is adiabatic process. So dq equals to 0. So du equals to mu cv dt for any process. dW equals to P dV V1 V2. So here P is what? We need to change here. P dV PV to the power gamma for adiabatic process. That is constant K. We will write here K as a constant because we want to have an integration here VV by V to the power gamma into K. So we can say here K gamma means 1 minus gamma 1 by V2 gamma minus 1 minus 1 by V1 gamma minus 1. If we cross multiply here, this is V1. P2 V2 minus P1 V1 by 1 minus gamma. And just remember one thing here, I'll write in a cloud that this is only applicable, capable, what is the spelling? Cable, yeah. In this process, that is adiabatic process. Okay, remember this. This is only applicable for adiabatic process, not for all other process. What this means, this one, P to the power gamma. Oh, okay. So let's draw this graph and we can finish it today. You have another class waiting. So this is what change of volume, and here P. So every point we can observe change of volume, change of pressure. Are you done? Shall I stop sharing? Okay then, everyone. Bye bye. See you tomorrow.
Bye, sir.
Yup.